Hello everybody, welcome to Guidancee Education channel. We will see the topic that is discussed in this video. We are continuing class 11 physics thermodynamics. Under that we will do work done and internal energy change for 1 isobaric process and 2 isochoric process. But before we start the topic, please watch the video completely so that you get all points cleared. And if you think the video is useful, do like the video, share the video with your friends who may also be benefited, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and support me. And also press the bell button and all button for notification of more videos like this. Thank you very much. Come, let us start the topic. Process. Pressure is constant. Imagine a system is taken from P1 V1 to P2 V2 isobarically, that is keeping pressure constant. The system is applied heat, but the pressure is not allowed to change. Let us consider two diagrams here. One is for expansion work. When heat is supplied, the volume increases. That is, the system works on the surrounding. This is V initial. We mark it as V1. And this is final volume, V final. We mark it as V2. This is the change in volume, dV, during expansion of the gas. The second diagram is for compression work. That is, work is done on the system. This is the initial volume V1. When heat is removed from the system, the volume decreases. Pressure is constant. This is the final volume V2. This is the change in volume delta V. We have to understand work done in isobaric expansion and compression work. Let us see the details. Pressure is constant means P1 is equal to P2, that is equal to P. Since these two are same, we can represent it as P. As pressure is constant, dP is equal to 0. There is no change. We have the formula PV is equal to nRT. From this we get V is equal to nRT by P into T. N is a constant, R is a constant, and P is a constant. So this quantity becomes a constant. So V is equal to constant into T, which is nothing but V is directly proportional to T. What is this? This is nothing but Charles' law. Okay. P1 V1 can be written as PV1 is equal to P2 V2 can be written as PV2 at constant pressure. This is equal to nRT. P delta V is equal to nR delta T. We have the thermodynamic equation. Delta Q is equal to delta U plus delta W. We already have the formula. Work done is equal to P delta V. P delta V is equal to nR delta T. So we can write work done is equal to nR delta T, which can be written as nR into T2 minus T1. So here, since pressure is constant, when heat is supplied to the system or heat is removed from the system, what happens? The temperature changes. We have already seen change in temperature is proportional to change in volume. Now let us apply this equation to expansion work and compression work and see what happens. dV is equal to V2 minus V1. For expansion work, V2 is greater than V1. So dV is positive. Charles' law says that V is directly proportional to T. So we can write T2 is greater than T1. So dt is positive. So work done nR into T2 minus T1 will be positive. Work done is positive for expansion work. So expansion work done in isobaric process, W is equal to nR delta T. For compression work, V2 is less than V1. So dV is negative. Similarly, applying Charles' law, we have T2 is less than T1. So dt is negative. So for compression work, negative work done is equal to nR into delta T. This quantity will be negative because for isobaric compression work, heat is removed from the system. Work is negative for compression work. From this equation, dq is equal to du plus dw. For expansion work, part of the heat that is supplied is converted to work and part is used to change the internal energy, that is temperature. Remember, for compression work, heat is removed from the system. For a given amount of heat, that is for a certain amount of heat supplied or taken away, in the case of expansion work and compression work respectively, change in temperature depends upon specific heat capacity at constant pressure of the gas. So that is what decides how much change there will be in the temperature. I hope it is clear. Now we will see isochoric process. Volume is constant in this case. The system is taken from P1 V1 to P2 V2 isobarically. But since the volume is constant, this V1 and V2 are the same. So V1 is equal to V2. So dV is equal to 0. The thermodynamic equation as per the first thermodynamic law, dq is equal to du plus dw. And work done is equal to P delta V. Delta V is equal to 0. Therefore, P delta V becomes 0. So, work done is equal to 0. So, no work is done. So, delta Q is equal to delta U. So, all the heat that is supplied is used for increasing internal energy and its temperature, of course. So, whether it is for expansion work or compression work, all the heat that is supplied is utilized changing internal energy and thereby temperature. The change in temperature depends on specific heat capacity at constant volume of the gas. Compare this with what we got for change in temperature in the case of isobaric process. I hope this video was of great use to you. If you think the video was useful, do like the video, share the video, and also leave your comments in the comment box. If you have not yet subscribed my channel, do subscribe it now and also press the bell button in order to get intimated as soon as new videos are posted. Thank you very much for your support. We will see in the next video with the next important topic. Till then, bye. Take care.